Hi, in today's video I have brought you a very nice problem of a Japanese Mathematical Olympiad edition 2002 question number 4. Okay, here is the following setup. We have a sub 1 through a sub n and b sub 1 through b sub n are positive numbers as real numbers n superior to 3, such that we have this sum as I goes from 1 to the n of a sub I equal to 1. Okay, second condition, we have the sum as I goes from 1 to the n b sub I square equal to 1. Okay, our goal, we are going to prove this sum as a sub 1 is multiplied by b sub 1 plus a sub 2 plus a sub 2 is multiplied by b sub 2 plus a sub 3 and so on and so forth until you got the last term, which is a sub n is multiplied by b sub n plus a sub 1. Entire thing is strictly inferior than 1. Okay, in fact this is very beautiful problem. We are going to use a lot of technique here in order to solve it. So now you can give a try to this problem by using the arithmetic mean value theorem, AMG. I'm going to remind you with that. Here is the following AMGM, which we are going to use in this problem. We have the sum as x1 through the xn is superior or equal to n is multiplied by the nth root of these numbers, which x1 is multiplied by x2 and all the way down to the xn. Okay, in fact this is very important and useful formula, especially for the students who are preparing for International Mathematical Olympiad. It's more useful. Let's jump into the solution now. It's very clear we are going to use absurd as a proof. We are going to assume this sum is superior or equal to 1. At the end of the term we are going to find a contradiction. Okay, let's go through it. Let's call this sum as a capital A. We don't have to put everything. Okay, this sum as a capital A is superior or equal to 1. Okay, I'm going to apply this theorem on individual term here. Okay, so I'm going to apply it on the first term. b1 plus e2 is superior or equal to, I have two terms here, 2 is multiplied by the product of these two numbers. b1 is multiplied by e2 square root 1 to the 1 over 2. Okay, then I'm multiplying both sides by a1. For the second term, I have b2 plus e3 is superior or equal to 2 times is multiplied by the product of these two terms. b2 is multiplied by a2 square root, so 1 over 2, so to the 1 over 2, and don't forget to multiply both sides by a2 and so on and so forth until you get the term before last term. Okay, be careful here because the last term is sub 1. That's mean it was a sub n minus 1. Okay, so I will have b sub n minus 1 plus e sub n minus n minus 2 superior or equal to 2 times is multiplied by this product, which is b sub n minus 1 is multiplied by this one, which is a sub n minus n minus 2. So I will multiply e sub n minus 1 on both sides. Last term I will have b sub n plus e sub n minus 1 is superior or equal to 2 times is multiplied by b sub n is multiplied by a sub n minus 1. Okay, multiplying both sides by a sub n. Okay, I'm going to sum this one. Okay, this one, as we said, as a capital A is superior or equal to, I will have 2 as a common factor 2 is multiplied by E sub 1 is multiplied by B sub 1 E sub 2 square root plus the second term E sub 2 is multiplied by B sub 2 is multiplied by E sub 2 square root of this one, and all the way down, plus these terms E sub n minus 1 is multiplied by B sub n minus 1 is multiplied by this one E sub n minus 2 is A sub 2 square root. The last term I will have E sub n is multiplied by B sub n is multiplied by E sub n minus 1 will be I will get E sub 1 here. Okay, so the square root. So everything is multiplied by number 2. Okay, now as I summed these terms, I get capital A superior equal to 2 is multiplied by this whole thing. Now what I'm going to do now, I'm going to apply this theorem, EMG theorem, second time on this one. Okay, so we have the capital A. Let's call this one as a capital B. So this one capital A superior equal to capital B superior equal to, so I have n term is multiplied by this one 2 to the 1 over n is multiplied by this product E sub 1 is multiplied by B sub 1 is multiplied by E sub 2 to the 1 over 2 is multiplied by E sub 2 is multiplied by B sub 2 is multiplied by E sub 3 to the 1 over 2, and all the way down to the before last term, the term before last term, I get E sub n minus 1 is multiplied by this product B sub n minus 1 is multiplied by E sub 2 to the 1 over 2 is multiplied by the last term, which is E sub n is multiplied by B sub n is multiplied by E sub 1 to the 1 over 2. So the whole thing is raised to the 1 over n as a power. Okay, so we have number 2, we have only one, we have number 2 is multiplied by the whole thing, which has 1 over 2 as an exponent as well. Okay, so what I'm going to do now, I'm going to select E sub 1 through the E sub n. I'm going to select those terms separately. I will put E sub 1 through E sub n in the front. We'll get capital A superior equal to this one, n is multiplied by 2 to the 1 over n. E sub 1 will be written on this form. E sub 1 is multiplied by E sub 2 and all the way down to the E sub n. Okay, so I will have this one like this is raised to the 1 over n as an exponent, then is multiplied by E sub 2 is multiplied by E sub 3 and all the way down to the E sub n minus 2 is multiplied by the last term, which is E sub n minus E sub n minus 1 is raised to the 1 over 2 as a power, then is multiplied by another product, which is B sub 1 is multiplied by B sub 2 and all the way down to the B sub n. Okay, to the 1 over 2. Then is raised to the 1 2 over n as a power. We'll put n here. Is multiplied by 2 to the 1 over n is multiplied by the n. Okay, as a common factor. Now, if you take a look carefully here, now on the other word, on the other side, I'm going to apply this theorem, EMG theorem, on both terms. I'm going to apply on this one first. So I have this one, this sum, E sub 1 plus E sub 2, E sub 3, and all the way down to the E sub n is superior equal to, I have n terms here. I have n terms in terms is multiplied by n, is multiplied by the product of this one, which is e sub 1, e sub 2, and all the way down to the e sub n, is raised to the 1 over n as an exponent. Okay, so this term equal to 1 as we have here. So on the other word, implies we'll get this term, which is n, is multiplied by this product e sub 1 is multiplied by e sub 2, and all the way down to the e sub n is inferior or equal to 1, is raised to the 1 over n as a power. So if you take a look at the first term, we have this one is this one exactly. So I'm going to leave this one for now. I'm going to work on this one now. I have e sub 2 is multiplied by e sub 3, and all the way down to the e sub 2 is multiplied by e sub 1. Okay, so this term as we have here is multiplied by n. So this term is the same thing as this term, just I'm going to multiply by n here. This term is the same thing as this one. This one is the same thing as this one, just to have the one term missing from this one, because here up to from e sub 2 up to e sub n minus 1. But don't worry about these small numbers, because we have the sum of these numbers equal to 1, which is very small numbers. So a few terms missing from this one doesn't affect our inequality, because they are very small numbers. Okay, so anyway, this one is inferior equal to this one. I'm going to take the square of this one. I'm going to divide by n on both sides. I'm going to divide by n on both sides. I will get 1 over n here. Then I'm taking the square root of this one. It become 1 over 2n. Here is a square root of this one. I will get 1 over square root of n here. So now I have this term is strictly inferior than 1 over square root of n. So I'm going to work on this term. So I'm going to apply the same theorem on this term. Okay, I have b sub, so I'm going to apply this EMG theorem on this term. I will do the same job. Okay, I will get b sub 1 square plus b sub 2 square, and all the way down to the b sub n square is superior equal to, I have n terms here, is multiplied by this product. B sub 1 square is multiplied by b sub 2 square, and all the way down to the b sub n square, all to the 1 over n. Okay, so I'm going to take off these squares. I put it as an exponent. I put it here. Okay, so this one equivalent, I'm going to flip this inequality. I will have n is multiplied by b sub 1 is multiplied by b sub 2, and all the way down to the b sub n to the 2 over n is inferior or equal to, as we said before, this term equal to 1, because equal to 1. So this one is inferior or equal to 1 as well. Okay, I'm going to divide both sides by n. Okay, then I'm going to, in order to get to this one, I'm going to raise 1 over 4 as an exponent. Okay, so we'll get 1 over 4 on both sides, 1 to the 1 over 4. Okay, I'm almost done. I get this term is multiplied by this term is giving us this term. Okay, I'm going to switch these two terms. I will get 2 to the 1 over n is multiplied by n. Now this term, as I have here, as this one, is strictly inferior than 1. Okay, then this term, what I have here, this one is inferior or equal to 1 over square root of n. Okay, then this term, I'm going to simplify out this exponent. I will get here 1 over 2n. So I will go back to the original one. So now I have the same thing as I have here. So this one, as I have here, is inferior or equal to 1 over n to the 1 to the 4 as an exponent. Finally, I will get capital A superior or equal to this term, 2 to the 1 over n is multiplied by 1 is multiplied by 1 over square root of n is multiplied by 1 over n to the 1 over 4. Okay, we're going to clean up the board and take this one at the top and continue with our calculation. Now I get to this expression. I'm going to simplify this calculation. I will get capital A is superior or equal to 2 to the 1 over n. I'm going to simplify this one. Square root of n is the same thing as n to the 1 over 2 is multiplied by n to the 1 over 4. I will get 2 to the 1 over n is divided. I'm going to simplify this fraction. I will get n to the 1 over 2 plus 1 over 4. I will get capital A is superior or equal to 2 to the 1 over n. This one is given as n to the 3 over 4. Okay, we have n superior or equal to 3. Okay, so I will have n superior or equal to 3 equivalent 1 over n is inferior or equal to 1 over 3. Okay, I'm going to take 3 over 4 as an exponent on both sides, over 4, and multiply 2 to the 1 over n on both sides. We have n is superior or equal to 3 equivalent to 1 over n is inferior or equal to 1 over 3. I'm going to take both sides to the 1 over n as an exponent. I will get 2 to the 1 over 3. Okay, superior or equal to this number, 2 to the 1 over n is divided by n to the 3 over 4, which is inferior or equal to these terms. I'm going to multiply this one by this one. I will get 2 to the 1 over 3 is divided by 3 to the 3 over 4. This term is strictly inferior than 1. Okay, by assumption capital A is supposed to be superior or equal to 1, but at the end of the term we found this term is strictly inferior than 1, which is a big contradiction. Okay, we have proven this one. If you have any question or suggest, just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.